Hello everyone, and welcome to this video on finding the maximum or minimum value of a quadratic function. Okay, so in this video we'll first take a look at what a quadratic function is again, and what the graph of a quadratic function looks like, right, a parabola shape, and then talk about finding the maximum or minimum output of that function, or maximum or minimum value. Right, recall that when you're asked for the value of a function, you're being asked for an output of that function, a y-coordinate, if you will. All right, and then then afterwards I'll show you several examples where I find the maximum or minimum value of a quadratic function. Okay, so on my first page, let's talk about quadratic functions real quick. So any quadratic function is a function that can be written in the following form. Right? It might not always start off looking this way, but it can be written this way, as f of x or y equals a times x squared plus b times x plus c, where the a, the b, and the c are real numbers, and a is not 0, right? The lead coefficient is not 0, because if it were 0, it wouldn't be a quadratic function anymore. Now, in a previous video, I did talk a little bit about some properties of these, quadratic functions written in this form, f of x equals ax squared plus bx plus c. And one of those was, you could tell very quickly what kind of graph you were going to have. The graphs of these are parabolas, right? These U shapes, these opening up or opening down. The value, if it's in this form, the value of the lead coefficient, the value of this a, will tell you right away whether or not the parabola is opening up or down. So, one, if a is positive, right, if the value of a is positive, then the parabola, the graph of the quadratic function, will be opening up. Right? In other words, looking at a picture, be looking something like this. Right? And if it's opening upward, that means that the vertex, right? So remember, the vertex is, in this case, the point at the bottom of the parabola, right? The vertex is at the bottom. In other words, the function would have a minimum value, right? Because there's going to be a point on the graph with a lowest y value. So another way to say the vertex is at the bottom is saying that the function has a minimum value. Right, it has a lowest y coordinate. And no maximum value, right? The graph would be going up forever on both ends. So there is no highest y coordinate, but there is a lowest y coordinate, right? Whatever the y coordinate of the vertex is, or that output. 2, that's if a is positive. If a is a negative number, right, less than 0, so -3, -5, whatever, then the parabola, the graph of the quadratic function, will open down, opens downward. So to put that in terms of a picture, we'd have a parabola looking, like this. And the vertex in this case, when the parabola opens down, would be that point at the very top. And another way to say that is that the function would have a maximum value, right? There would be a highest y-coordinate, a highest output. And then, there is no minimum, there is no lowest output because, it's going down forever on both ends. There's no lowest y-coordinate, but there is a highest y-coordinate. All right, the function in this case would have has a maximum value. Right, so that's a really easy way to tell if a quadratic function is going to have a maximum value or a minimum value. Right, just put it in this form and look at the lead coefficient. Is it positive? It'll have a minimum value. Is it negative? It'll have a maximum value. All right. And let me make that note as well. I've mentioned that when I say the value of a function, right, I'm talking about y coordinates, y values, outputs. So let's make that note. So note here the maximum or minimum value of a function is an output. Right, it's an output, a y coordinate, if you want to call it that, a y value. Pardon me. Okay, now another property of the function, f of x equals ax squared plus bx plus c was, I've mentioned the vertex, right? This lowest or highest point where the minimum or maximum value occurs. You can find the coordinates of the vertex very easily, and again we saw this in a previous video on graphing quadratic functions of this form, y equals ax squared plus bx plus c. The vertex has these coordinates. Right, so the x coordinate, the input, where you take the opposite of b and then divide this by 2 times a. So you take the opposite of the linear coefficient, right, the number times the x to the first power, that's the numerator, and then divide that by, and then 2 times the quadratic coefficient, the x squared term coefficient, 2 times a. That's the denominator. Comma, right, that'll be the x coordinate or the input, and then you just take this number and plug it into the function, right, plug it in for x. What is the value of f at this input? So the y coordinate would be the value of the function at negative b over 2a. Right? So I would just go through the rule and replace all the x's, with whatever negative b over 2a is, and get the output, and that'll be the y coordinate of the vertex. And as I mentioned up top here, this value right here, this y coordinate, what the value of f is at negative b over 2a, that's going to be either the maximum or minimum value of the function, depending on whether or not the parabola is opening up or down. And that's really all we need to know here to get into the following examples. So my first example, and my first couple examples, had the same instructions. So in this first one, I'm asked to determine whether the quadratic function has a maximum or a minimum value. And again, that's real simple if it's in the form ax squared plus bx plus c, which this one is. Then find that maximum or minimum value of the function and where it occurs. Right. So as mentioned, this maximum or minimum value of the function is a y value, is a y coordinate, and where it occurs is the x coordinate, the x value. Right? That's what's the input where that maximum minimum y value happens. Right? Okay, so here my function is f of x equals 2 times x squared minus 8 times x plus 1. This is in that ax squared plus bx plus c form. In fact, I'll identify what those are. The value of a would be positive 2. The value of b would be negative 8. Don't forget this is really plus negative 8x, so don't forget the negative. The value of c would be the positive 1, the constant term there. Alright, so look at the value of a. It is 2. The lead coefficient is 2. That is a positive number. Right? 2 is greater than 0. A is greater than 0. Meaning that the parabola, the graph of the parabola, opens up. Right? Looking like this. So the vertex, right, the point we're going to be looking for is at the bottom of the graph. It's the lowest point. So that tells me that the function has a minimum value, right, a lowest y-coordinate. Okay, so that's part one of our answer, right? That's what part one of what we were asked to find. Determine whether the quadratic function has a maximum or minimum value. The function has a minimum value because the lead coefficient is positive. Now actually find this value and where it occurs. Well, the where it occurs part is simple. That's the negative b over 2a, right? Where the minimum value occurs. Say min, okay, min for minimum value. Where the minimum value occurs is here. The x coordinate of the this is just the x coordinate of the vertex. X value of the vertex. All right. And the x value of the vertex I put on the previous page was that, remember, opposite of b divided by 2a, if I'm in that ax squared plus bx plus c form, right, which I am here. So it's the opposite of negative 8 in the numerator and then 2 times 2 in the denominator. So the x coordinate of the vertex is positive 8 divided by 4. 8 divided by 4 is positive 2. So this is the value where the minimum value of the function will occur. And then the actual minimum value of the function that's the y value of the vertex. All right, and that's going to be the value of f, right? This function's called f here, when x is 2, right? What's the value of f at an input of 2? This input here, right? So I just go through the rule. This is how you calculate the output. Replace all the x's with 2. So it's 2 times, 2 squared for, instead of x squared, minus 8 times 2 instead of x, and then plus 1. And we simplify this. 2 squared is 4. 2 times 4 is 8. This negative 8 times 2 is negative 16. 8 minus 16 is negative 8. Plus 1 is negative 7. So this, right, negative 7 is the minimum value of the function, the y coordinate of the vertex. All right. And I'll write that out in a full sentence on the next page here, just sliding this up a bit. So the way I would answer this, right, I would just say that the minimum value of f. Right, so the way I would answer this is this way: the minimum value of f, right, of function f, that's what it's called, is negative 7, and this occurs at x equals 2. That is what I was asked for. Right? Find that minimum value, and also state where it happens, right? Where it occurs. What's the input? Wonderful. All right, so yeah, just does it open up or down? You'll tell right away if it has a maximum or minimum value. Then find that negative b over 2a, right? That's where the maximum or minimum will occur. Then you plug that number into the function and get your maximum or minimum value, right? Whatever that output is. Great. So I've got another example here where I'm asked to do the same stuff, right? I'm asked to do the same instructions. Determine whether the quadratic function has a maximum or minimum value, and then find the maximum or minimum value of the function and where it occurs. Right? So this one's a function g called g. So output g, input x. Right? So still the same input variable, but the output's called g this time instead of f. No, not a big deal. So g of x equals negative 1 times x squared plus 10 times x plus 8. All right, so it's in that form I like, right? The ax squared plus bx plus c form. Let me get rid of the instructions here. We'll just work through. And off to the side again, I'll do it underneath this time. All right, so the value of a is, again, the coefficient of x squared is negative 1. The value of b is positive 10. The value of c is positive 8. And look at the value of a. Right? Look at that lead coefficient. Negative 1 is, less than 0. It's negative. So that means that the graph of this, if you were to graph it, it's the graph of the parabola, and I'm not going to make the graph. You can just you know what it's going to look like. The parabola opens down, meaning it'll look something like this. Frowny face. So the vertex is at the top. That means the y-coordinate of the vertex will be the highest y-coordinate of the entire graph. So that means the function has a highest value, a maximum value. All right, so the function g, all right, this function called g, has a maximum value. Wonderful. And that was part 1 of the answer, right? Just determine whether or not the function has a maximum or minimum value. Great. And then we're asked to find, what is this maximum value, right? Which is, again, the y-coordinate of the vertex. And where does it occur? The x-coordinate of the vertex. All right, so the easiest one to find is that x-coordinate of the vertex. So, again, where the maximum value occurs, right? The x value of the vertex, that's at x equals that negative b, the opposite of b divided by 2a. All right, so the opposite of b was negative 10. Divided by 2 times a is negative 1. So we have x equals negative 10 in the numerator, negative 2 in the denominator. Negative divided by negative is positive. Negative 10 divided by negative 2 would be positive 5. All right, so this is where the maximum value will occur on the graph at x equals 5. But this, again, 5 here, the x-coordinate, is not the maximum value. This is just where it's happening. The actual maximum value of the function, that's the y-coordinate, the output at x equals 5. So the maximum value of g, right, this function g, right, this is again the y-coordinate, the y value or the output of the vertex. So that's just what is the value of this function g when the input, when x is 5. So I'm just going through the rule and finding what's g of 5, right? Replacing all the x's with 5. So that'd be negative 1 times 5 squared. Not negative 5 squared, right? It's negative 1 times 5 squared, Right, so this is going to be negative 25, not positive 25. Plus 10 times 5, and then plus 8. Right. So like I said, this is negative 25 plus 50, which would be positive 25, right? Negative 25 plus 50, positive 25. Then plus 8 be 33. And there's the y coordinate of the vertex, the output when this x is 5, and this is the maximum value of our function, the largest y coordinate, the largest output you could possibly get no matter what you plug in for x. The highest output is going to occur at x equals 5, and that maximum value will be 33. All right, and again, I'll write this out in a complete sentence. All right, the way I would answer this on an assignment. Right. So the maximum value of g the name of the function was g, right, is 33. And this occurs when x equals 5. Right, and that's how I would answer that particular question if I was given that on an assessment of some kind. Pardon me again. All right, now I've got one last example where I'm basically doing the same stuff. All right, it's just in the disguise of a word problem, but I'm really going to be doing the same thing I did in the past two examples. All right, let me show you. It's a problem where I'm asked to, maximize revenue for a company. Right? So here again, it's the same problem, just disguised as a word problem. All right, so suppose that the marketing department of Texas Instruments, the company, right, has found that when a certain model of calculator is sold at a price of P dollars, so P is a variable here representing the amount of money that they're selling a calculator for, right? A certain model, let's say the TI-83 or TI-84, right? When a certain model of calculator is sold at a price of P dollars, the daily revenue, R, also in dollars, as a function of the price P, is this function here. So R of P, so the output is R, this revenue. Right, now revenue is just the money brought in by a company, right? So all the sales, right, bring in money to the Texas Instruments. So the money brought in, R, is the output, and the input is price, right? The price of the calculator, the price that they're selling the calculator for, P. So R of P equals, and then here's how the output is calculated, right? You take negative 1/2 or negative 0.5 times the price of the calculator squared plus 75 times the price of the calculator. See how this is a quadratic function? And I'll say this right now. I mean, this isn't any different from, say, f of x equals negative 0.5 x squared plus 75x, right? But instead of x, it is, my input variable is p, and instead of f, my output variable is r, right? So again, no different really though, right? We're going to treat them the same. All right, and then I have two parts to this, two questions, and they'll again be like I did in the last two examples. First question, for what price will the daily revenue be maximized? Right, notice the word maximize. They might be out there. You might come across other problems where they ask about minimized, right? But you see why it's maximized here. Look at the lead coefficient. They're asking about where the revenue is maximized since the lead coefficient is negative, right? Again, this is in that form ax squared plus bx plus c, right? In fact, I'll write that out. Right? The value of a, the lead coefficient, is negative 0.5. The value of b is positive 75, the linear coefficient. And the value of c is 0, right? There's plus 0, but nobody ever writes plus 0, but the value of c would be 0. But you see, the value of the lead coefficient is negative on this quadratic function in this ax squared plus bx plus c, or ap squared plus bp plus c, if you're using p instead of x. So if you were to graph this on a coordinate plane, say the horizontal axis was the p-axis and the vertical axis was the r-axis, it would be a parabola opening down. So that's why you have a maximum value, right? A parabola opening down. That's why they're asking about revenue, the value of R, right? This daily revenue is R being maximized. So the question is, for what price? Well, that means what's P? P equals what? Right? What price? What is the So what is the value of P that I would need to plug in to get the largest possible value of R? Well, that's just finding the vertex. That's just finding the input value of the vertex. So this what price here, we're finding the P value of the vertex, or the input value, right? This is like the examples earlier when they ask, where does the maximum occur? Where does the minimum value occur? This is like asking that same question. For what price will the maximum revenue occur, right? So remember how to find that, right? How to find that input value, that x value, or p value in this case instead of x. You take that opposite of b over 2a, right? So the opposite of b, that's negative 75 divided by, and then 2 times a would be 2 times negative 0.5. So p equals, negative 75, and then, 2 times negative 0.5, well, that's 2 times negative 1/2, that'd be negative 1. Negative 75 divided by negative 1 is just positive 75. All right. So the way I would answer the question, right, because it is a word problem, most of the time word problems, when you answer questions in word problems, you should be answering in complete sentences, and also, throw units on your numbers so that it gives them meaning, so they actually make sense with the problem, pardon me there. So the answer to this question is, for what price will the daily revenue be maximized? The way I would answer this, I would answer it saying the daily revenue will be maximized. Sorry, that's so tiny there. That says maximized. The daily revenue will be maximized when the price of a calculator is $75, or just say when the price is $75. Right. So notice I threw a unit, the units on this number to give it actual meaning, right? And the price was in dollars, right? P dollars. Okay, so again, this was just like asking in those earlier examples, where does the maximum occur? That's the x coordinate of the vertex, or the first value, and in this case, instead of the x coordinate, right, it's the p coordinate, that negative b over 2a. All right, now that I have this, the very next question that follows is, like we did in the previous examples, now that I've found the input for the vertex point, what's the output? What is the maximum daily revenue? And again, what is daily revenue? That's an R value, right? That's a value of this capital R represented revenue. And this is the R value of the vertex, right? The maximum daily revenue is the R value of the vertex. So we just need to find what's R, right? The value of the revenue when the price is $75, right? We said in the previous part that when the price is $75 for a calculator, they'll have their maximum revenue. So what is R of 75? Okay, So I put that in. That's negative 0.5 times 75 squared plus then 75 times 75. Right. Now you could punch this into a calculator if you want. I don't know, something I'm noticing is that really these are both 75 squared. Both of these have 75 times 75 really. So you could factor that out. And then you'd have negative 0.5 left over in the first term. And if you pull out 75 times 75, you pull out 75 squared from the second term, it's just plus 1. And then, negative 0.5 plus 1 is just positive 0.5. So it's 75 squared times a half. Right? So whatever half of 75 squared is. Well, 75 squared is 5,625. Right? And then you're multiplying it by a half. So that'd be half of 5,600 would be 2,800, and half of 25 bucks is 1,250. So 1250. $2,812.50. I'm just going to double check that, right? I always like to, I say this on all the videos, double check your answers. So I'm actually going to punch this in the calculator too, just to really make sure that I did this right. So negative 0.5 times and then 75 squared. And then after that, plus 75 times 75. And it's, 2812.5, 2,812.5. All right, great. Now again, that's not the way I'm going to answer this. I know I put dollars here, right, because it's in dollars, it's revenue, but I'm going to answer it in a complete sentence. Right? So the way I would answer this, the question is, what is the maximum daily revenue? Just simply the maximum daily revenue is $2,812.50. And that's how I would answer this if I was given this on an assignment or in part of a quiz or a test or something, right? It's a word problem. You should be answering your word problems in complete sentences with units on your numbers to give them meaning. Great, but you see how this problem was no different than the first two examples, right? I was really just taking a quadratic function, right? This is a quadratic function up here, but instead of p you have x, instead of x you have p, and instead of f you have r, but it's really no different. And then use that negative b over 2a, right, to figure out where the maximum or minimum will occur. And then you plug that negative b over 2a number in and then actually find the maximum or minimum value, right? In this case it was maximum revenue, right? And the where it occurred was, what price would cause you to have a maximum revenue, what price would the maximum revenue occur at. Great. Alright, as I like to say at the end of these videos, do the best you can to learn the material on your own before you go looking for help. I've found over the years that people who take the time and the effort to learn something on their own tend to remember that material better and far longer than if they just immediately went to a tutor and had it, because I know how tutors and stuff help people. They usually just end up doing the problems for you in some roundabout way, and you don't really learn anything unless you have a really good tutor who actually teaches you to think for yourself and do things on your own. Just kind of guides you. So obviously read the material, right? Read through the author's examples. Perhaps even try to work out the solutions to an author's examples before you see how the author did it. And then compare your work with the author's and see if you can't learn from some mistakes there. Obviously do tons of exercises, practice problems. Practice makes progress. It's the only way to get better. Look up solutions to those if they're made available to you so you can check how you're doing, keep track of your progress. And don't give up on a problem or an exercise after just one or two attempts. Very often in mathematics there are several approaches that'll work for any particular problem. So, if after several attempts at a problem, several different approaches, you're still having trouble, still struggling, I would suggest to you actually go back and read the material again, perhaps even a third time, more slowly, more deliberately, take good notes. If you hadn't taken notes before, maybe organize your notes into a way that makes it easier to read. But the reason I say this is because if you've been working on problems as you should, you probably you'll more likely have a better idea as to what the author wants from you in that material, what the author thinks is important about that material, so then when you go back and read again, you'll have a better notion as to what the author thinks is important. You'll have a better notion as to what the author wants from you. So you'll know better what to look for in the reading. And maybe some things will pop out at you that didn't the first time. It will make working on the problems that much easier. But if after that, if after several read-throughs of the material and several approaches at the problems, you're still having trouble, still struggling, it is not a sign of weakness whatsoever to go looking for help, asking for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental material online. There's tons of it out there. Look for videos online, videos like this one, or plenty of other videos out there that are better than this one. I assure you they're out there and they're easy to find. But just keep at it, stay persistent, keep practicing, don't give up. And above all, and I think this is the hardest thing for most people, stay positive. Right? Believe in yourself, believe in your ability to make it through these struggles and frustrations and mistakes. Because it's in those moments when you're struggling and you're failing and you're making mistakes and you're frustrated. It's in those moments when you have the opportunity to learn the most and learn the most deeply. Because if you can persevere, if you can persist and work through it and work through your frustrations and learn how to fix your mistakes, man, you'll remember that material far better and far longer than someone who just got it right the first time and breezed through and didn't even give it a second thought afterwards. Okay, so stay persistent, keep practicing, stay positive, all right? Stay positive, believe in yourself, and don't give up. And I just know you'll get it. And thank you very much for watching.